Hello everyone, welcome back to Smart Interviews YouTube channel. I am Thakur Rishi Singh. Today we will discuss problems from LeetCode Weekly 395 contest. Let's start with the first problem. The first problem says that you're given two arrays, and yeah, both arrays are of same length, and it says that the array one, each element has been increased with an integer. As a result, the array one is equal to now array two. Okay. Two arrays are considered to be equal when they have the same integers with the frequencies. So they are depending on the frequencies, not on the arrangement. You need to certainly return the text. Okay. So the problem seems to be quite easy. Let's see. Let's consider. Let's consider this is my nums one. I will take a general example A B C D, and my nums two is like P Q R S, and it is said that nums one elements, every element is increased by some certain value of x, and you need to find this x. Okay, so now let's consider. Can you tell me what is the range of x here? So to understand the range of x, let's take an example here. What if I say my a here is 0 and p is here 1000? So can you tell me what is the value of x here? The value of x here, I can say it as plus 1000. And if I say like in the reverse order, if my a was 1000 and p was 0, can you tell me what is my x value here? Obviously, here my x value seems like minus 1000. And as you might have seen the constraints, let's go to the constraint here. The constraints are like my array values will only range from 0 to 1000. So that's why I've taken here 0 and 1000 as the examples. Okay. Now, as I know, now the range for x belongs to from minus 1000 to 1000. Okay. So now I know the range of x. Okay. So now what I will do is I will iterate on the range of x. Every time I will set, let's say, minus 1000 as my x. I will add this value for every element in nums1, and I will check is my nums1 and nums2 are same or not. If not so, I will change to some other value of x. Okay. Let's understand with a practical example. Let's select our first example 264 and 975. So here my nums1 is 2 1 second 264 and my nums2 is 975. Okay. So how my logic will go is like it will start from minus 7, minus 999, minus 998, 997, and it will at some point go to 3. Okay. At some point it will go to minus 1, 0, 1, 2, 3, and it will go till 1000. So for comparing nums1 and nums2, I will consider here a hash map. Cool. For here, I'll be using hash map 1. Here, I'll be using hash map 2. So every time I'll be adding this x values to num. Okay. And ideally, I won't be changing nums2. So I'll be creating hash map 2 at initial itself, and I will not change it. So let's create the hash map 2 here. So hash map 2 will look like 9, 1, 7, 1, 5, 1. Okay. And nums2, if I fix my x as minus 1000 it will be like plus minus 1000 plus minus 1000 plus minus 1000 here. So my hash map 1 comes here like 2 plus minus 1000 is minus 998. Its frequency is 1. Minus 994 minus 996. Okay. So is my hash maps equal? No, they are definitely not equal. So let's move to the other value of k, and I will repeat the same thing. I will generate the hash map 1. I will compare both the hash maps. So at some point, my k will come to 3 here. So what was the answer for current example 3? So let's check. My x is equal to 3. My hash map 1 will be like plus 3, plus 3, and plus 3. So it will be like 2 plus 3 will be like 5 comma 1. 6 plus 3 will be like 9 comma 1. 4 plus 3 will be like 7 comma 1. So now I will iterate on each value of hash map 2. If I have I will compare if I have 9. Yeah, I have 9. So I will also check if the values are equal or not. Yeah, the values are also equal. So I can say that the current value is fine. I will check the next value 7. Do I have 7? Yeah, I have 7. Compare the values 1 1. Yeah. Do I have 5? I have 5. Compare the values 1 and 1. So yeah, this is my required answer, and I will return 3 as my output. Okay. So this is going to be my approach. Let's try to code it up. Okay. So first step, I need the size. Since both the arrays are same, I'll be taking one array size only. Then I require a hash map. Hash map integer. So I will call it as hash map 2 since I'm storing the values of nums2. New. Okay. Now I'll fill my hash map 2 with the values of nums2. 1 second. Okay. So I'll put my hash map nums2 value here. If I have nums2 value, it's fine. If I don't have that value, okay. If I don't have that value, I will keep the default value 0. And yeah, whatever I get, I will keep it plus 1. Okay. So the next step comes is like I will iterate on the range of x for int my x starting from I will start from minus 1000 and I will go till plus 1000. Okay. First step is done. In the next step, what I will do is I want a hash map for nums1. Yeah, I think I can reuse my previous code. Yeah, I think, yeah, wait a second. So hash map 1, since I'm filling the values of hash map 1 with nums1, wherever I find 1, wherever I find 2, I will just replace it with 1. Yeah, done. Once I've created a hash map, And yeah, don't forget that hash map 1 we are creating, but with the value of plus x. Now, once I've created my hash map 1, I will now check if my hash map 1 and hash map 2 are equal or not. So I will iterate over hash map 2. I will use here map dot map dot let's say entry integer comma integer and reset if my I will check that in my hash map 1 I will check if I have that key or not. If I have my if I have that, okay, it's the hash map 2. I will check if I have hash map 2 key or not. If I have that key, I will also check if the values are same or not. Hash map 1 dot get v dot get key with the e dot get value. If it is same, I will just continue. Otherwise, in all other cases, I will return false. So I will not just return here. I will just mark it as false. So since I've used the variable flag here, I will declare above the for loop boolean flag. Initially, it's true. Whenever the first if condition is false, it will mark it as first if condition is false, then it will be false. If it is false, I can just break this at point. And so after this for loop, when both the hash map and hash map 1 and hash map 2 are same, and still my flag is true, I will just return the x from here. And yeah, just to return something at the end, I will return -1. Cool. Let's try to run our code. Okay. Okay. Sample test cases are passed. Let's try to submit our code. Okay. Cool. So you can also do the current problem by sorting the two arrays. It will be easy solution. You can find out it. But yeah, I think this is the standard way for to do this problem. And this method will also help us to solve our next problem. Let's go to our next problem. The next problem is a variation for the first problem itself. In the second problem, I can see that our nums1 array has two more extra elements in the given input. So you can skip two more extra elements, and once you have skipped two more extra elements, the other elements are incremented by some value of x, because of which my nums2 is equal. I need to return the minimum value possible for x. Okay. So the logic is still same. The only condition is in our previous thing, we were checking here while we were checking both the hash maps. We have a thing like we're checking in my hash if in my hash map 1 in my hash map 1 I have the key or not, which is fine, which is correct. We should at least have that key. But we were also checking like in my hash map 1 the key whatever we are getting e dot get key, whatever value we have in hash map 1, it can it can now be greater than or equal to whatever value we had in hash map 2. So I can e dot get value. Okay. So don't mind the syntax here. So overall, here E means it is belonging to hash map 2, this part. Okay. So here, what can the situation be like? Since my hash map 1 has a greater size, it can have like 6 comma 1 here, and let's say one more extra variable here too. 7 can be repeated twice. So in such case, it should be marked as valid. You have 7, but the value is greater when compared you need it. So if it is greater, it is enough for, so I can take it as like greater than or equal to. And even if we have some extra key, it's fine for us. So the only change in the code will be like, let's go back to our code. It will be very similar to our first solution. Okay. Let me just copy our previous code. And yeah, since the sizes are also different, let's take the size of nums2 nums2 dot length, and I will replace n with m here. The only change will be like here at this point. So let's try to run our code. Okay, it's nums. Let's try to submit our code. Yeah, it got submitted. So both the problems were same. They only added some additional condition that nums1 will have 2 extra elements. You need to skip it. That's it. Let's go to the third problem. So let's start with the third problem, minimum array end. So here you're given two positive integers, n and x. Okay, you're given two integers, not positive, n and x. You have to construct an array with. You have to construct a positive integer array of size n. And here we have two conditions. The array should be strictly increasing, and the and all the bitwise, and if you do a bitwise and this array, you need to get bitwise and equal to x. Okay, so depending on this, you need to get the minimum possible value for the nums of n minus 1. That means last value in your array should be minimum, as minimum as possible. Okay, I hope the problem statement you have it's clear. So let's try to understand in depth. Let's try to understand in depth. Um, you're given, let's say, two values. Let's say n equal to 4 and x equal to 5. So as we have seen, we have two major conditions. One is array should be strictly increasing, the array which you are constructing, and the second condition is your bitwise and your bitwise and of array should be equal to x. Okay, these are the two major conditions you need to follow, and at the end you need to output as array of n minus 1. That means the last element in the array. Cool. So first we'll see the second condition. If you want bitwise and equal to x at the end, that means, let's say this is my 0th element, first element. Here I have second element and third element. Okay, these are the four elements I have here. And if I do XOR for all this, at the end, I should get like at least 0, 1, 0, 1, which is nothing but 5x. Okay. If I want to get 1 here at these positions, that means all the bitwise positions of 0 should be 1 here. All the bitwise positions for 2 should be 1 here in all their elements. If you have, let's say, at least 1 0, then this will also become 0. Okay. Now, but we can keep any value over here, right? Okay. We can change the values that you can keep here. Okay. So, can you tell me what can be the minimum possible value that you can keep at this x positions? It will obviously be 0 and 0. Why? Because this is the minimum value that you can place at 0th position. So what you can place at 1? You can place 0 1. At 2 you can place 1 0. At 3 you can place 1 1. If you see, we are going in nothing but an increasing order. If you consider only the red elements, it is 0, it is 1, it is 2, it is 3. So I hope you're able to see some observations. In the return, you need to at the end you need to return the last element, which is nothing but 15 here, our output. Okay. So let's see if this is working with the given example. So here given n equal to 3 and x equal to 4. Let's see. If I place n equal to 3 and x equal to 4, let's consider 4-bit notation. And here, in the answer, you need to have this bit set. Why? Because 4 is nothing but this, but you can change these positions, right? 0th position, 1st position, and your 3rd position. So if it is 3, what's the, if you want 3 elements, the last second element will be 2. So I can say it as n minus 1, which is nothing but 2. 2 in binary we can write as 1 0. So do we have, or let's say 0 1 0. So this bit is not set in x, but it is set in, but is it set in 2? No. So what we'll do is we will ignore it. Next we are at here. So is this bit set in x? No. Is it bit set in n? Yeah. So even make set here. Now, is this bit set in x? Yeah, it is set in x, so ignore. Now, is this bit set in x? No. Is it bit set in n minus 1? No, ignore it. So we got the output as 6. And what do we have output there? It is 6. Yeah. So let's try to implement this. Let's try to implement this. So first, I will definitely need a variable answer. And answer, I'm making it equal to x. That means in answer, x bits will be set by default. Now, I will decrement the value of n here before itself. Now I will iterate on all the possible range from 0 to 60, let's say. Okay. Now, next I will see if it is set in x. If the ith place is set in x, I will just ignore it. But if it is not set, let's say if it is something like answer and, or I will say it as x and one left shift, let's put as 1l left shift of I. If it is not set, okay, if it is not set, So this if condition means if ith bit is not set in X, in that case, I will see is this set in, is the current bit set in N or not. So I will compare it something like N and 1. If it is not equal to 1, okay. In such case, I will simply, if it is set, I will simply set it in the answer. 1L left shift of I. Now, if it enters the outer if condition, I will by default update my N. I will just move one bit towards the right. And yeah, at the end I will return my answer. That's not set in 1. Okay. Then try to run our code again. Yeah, let's try to submit our code. Okay, cool. Yeah, guys, that's it for this video. If you have liked our content, do smash that like button. And if you want such more content, uh, follow Smart Interviews YouTube channel. And yeah, Rishi Singh signing off. Meet you in our next video.